express the series, as they give us here, as a rational function. We see the answer. How'd they come up with it? Well, what we want to use, I'm going to go back. This is the notes. This is the chapter 6 power series notes. Here's the formula. Let's use that. It's also here, any of these are, well, same thing. Okay, so I'm going to write that one down. So it says that 1 over 1 minus x equals the sum from n equals 0 to infinity of x to the n, right? It's right here also, right? And it's up here at the very top. It's the main one we use. Okay, it comes from the geometric series. Anyway, this is what we're trying to answer though. Okay, so I'm going to use, so here's what I'm going to use this. Use this. They're asking me to find this, which is the sum from n equals 0 to infinity of 1 over x to the n. Now, how can I find this using this? Well, basically, this right here, think about what this says. This says if you have the sum of anything to the n power, it's going to be 1 over 1 minus that thing. Remember, whenever we have an x in a math or science formula, it's like the holes in a toaster. It's the insert slot. So if I could rewrite this really simply, this says if you have the sum of anything to the nth power, right, that's going to equal 1 over 1 minus that thing. That's what that formula says. That x is just holding a spot. Don't let that x confuse you in a math or science formula. It's just like the holes in a toaster holding a spot. So it says if you have the sum of anything to the nth power, it's 1 over 1 minus that thing. Okay. Well, do I have the sum of anything to the nth power? You might say, problem is he's on the bottom, right? Right, but we can rewrite that. We can say that that's equal to the sum when equals 0 to infinity of 1 over x to the nth power, right? Because that's the same thing. That n goes there, n goes there. Into the 1 is just 1. Nothing's changing there. That's x to the n. The same thing. So now we have, it says if you have the sum of anything to the nth power, we have the sum of something to the nth power. We didn't have that back here. Wasn't as clear. We had 1 over something to the nth power. That's different than just something to the nth power. See that difference? We got to make the structure the same. I call it plastic surgery. Got to give it a new look so it matches the formula. Remove the wrinkles, same person, right? That's what we're doing. Right here, it didn't have the right look. It's supposed to be one thing or something to the nth power. Here, you think, we had something to the nth power. Yeah, but then there's something else too that's not to the nth power. See the problem? I got to rewrite this as something to the nth power. Now I can use this fun. Plug in the something, plug in the something. So now that's going to definitely equal 1 over 1 minus that something, right? We're just sticking right in here on 1 over x and on 1 over x, right? Match, and so it equals this. So there's our answer, except we got to clean it up. We don't like complex fractions, so multiply top, bottom, and here as well is over 1, so it cancels. So what do you get? X times 1 on the top is x. X times 1 right there is x minus 1. And there is our answer, which we already knew was right there. And so there we go.